The following guide has been produced for the Farm Advisory Service (FAS) as part of the Soil and Nutrient Network programme, with financial support from the Scottish Government. The guide has been compiled by the SEC consulting team in Dumfries as part of the delivery of the Soil and Nutrient Network programme at Limekilns Farm near Annan, Dumfriesshire. The aim of the guide is to help farmers to evaluate more accurately the potential nutrient value supplied to crops from applications of organic fertilisers, such as from livestock, slurries and manures. The hope is that by providing farmers with a better understanding of the nutrients that may be supplied from the applications of organic fertilisers, two main benefits will arise. First, it should help to avoid the over-application of organic fertilisers and, with that, reduce the risks of diffuse pollution. Secondly, it should also help farmers to make better use of organic fertilisers, with the potential to reduce the total cost associated with the purchase of artificial or inorganic fertilisers. The nutrient content of organic fertilisers or livestock manures varies widely and is dependent upon the type of stock, diet, feeding system and bedding used. Here, for instance, you can see that whilst farmyard manure, or FYM, is stored for 3 months or more, contains roughly the same amount of phosphate and potash as the farmyard manure being stored for less than 3 months, the FYM stored for less than 3 months contains almost double the amount of crop available nitrogen. Although it is relatively low in nitrogen content, cattle FYM contains useful amounts of potash, shown here as being approximately 8 kilos per tonne of FYM applied. Cattle slurry is shown here at 6% dry matter. However, the dry matter content of slurries can vary widely depending upon the animal diet, slurry storage system being used on the farm, and the volume of rainwater entering the slurry store during the year. Typically, slurry dry matters can range from as low as 2% dry matter for slurries held in lagoons, up to around 10% dry matter for slurries held in covered stores, for example, in underground cellars below slatted buildings. Pig FYM contains similar levels of potash to cattle FYM, but pig FYM is noticeably higher in phosphate content, typically being around 6 kilos of phosphate per tonne of FYM. Broiler or turkey litter is one of the most nutrient-rich manures around. It contains high amounts of all 3 major nutrients, typically 10.5 kilograms of nitrogen per tonne, 25 kilograms of phosphate per tonne, and 18 kilograms of potash per tonne of FYM. In order to help us work out an estimated monetary value of the nutrients held in organic manures, it is essential to have an up-to-date list of current market prices for inorganic or artificial fertiliser products. The list shown here shows the market prices for 7 commonly used artificial fertilisers. For the purposes of the example that we're going to look at, we're going to use, first of all, ammonium nitrate as a source of nitrogen, priced at 242 per tonne. Secondly, we're going to use triple superphosphate as a source of phosphate, priced at 290 per tonne. And third, we're going to use muriate of potash as a source of potash, priced at 265 per tonne. In this example, we're going to estimate the value of nutrients derived from the application of FYM, or farmyard manure, to grass. First, we need to consider the nutrient values within each tonne of FYM being applied to the land. In this instance, there's 0.6 kilograms of nitrogen per tonne of FYM, 3.2 kilograms of phosphate per tonne of FYM, and also 8.0 kilograms of potash per tonne of FYM. As stated in the previous slide, we're going to price the nitrogen at 242 pounds per tonne, phosphate is being priced at 290 pounds per tonne, and potash is being priced at 265 pounds per tonne. In order to calculate the monetary value of nitrogen in FYM, we consider the following. First of all, ammonium nitrate, or AN, contains roughly 34.5% nitrogen. 1 tonne of product, or 1,000 kilograms of the physical product, contains 345 kilograms of nitrogen. Therefore, if 1 tonne of product costs 242 pounds, we know that the 345 kilograms of nitrogen also costs 242 pounds. Dividing both sides of that equation by 345, we can say that 1 kilogram of nitrogen costs 70 pence. We know from our earlier slide that there's 0.6 kilograms of nitrogen in every tonne of FYM. Therefore, 0.6 times 70 pence means that there's 42 pence worth of nitrogen contained in every tonne of FYM. The calculation for the value of phosphate in every tonne of FYM is similar to that calculation we've just seen. If we're using triple superphosphate as our source of phosphate, we say that the triple superphosphate contains approximately 46% phosphate. Therefore, 1 tonne, or 1,000 kilograms of the physical product, is going to contain 460 kilograms of phosphate. If 1 tonne of product is costing us £290, then by definition we can say that 460 kilograms of phosphate also costs £290. If 460 kilograms is costing £290, then 1 kilogram of phosphate equates to 63 pence. We know that there's approximately 3.2 kilograms of phosphate in every tonne of FYM, so 3.2 times 63 pence comes to £2.02 worth of phosphate in every tonne of FYM. Similarly, for potash, we can say that muriate of potash as a source of potash contains roughly 60% potash. Therefore, 1 tonne of the physical product contains 600 kilograms of potash. If 1 tonne of product is going to cost £265, then we can say that 600 kilograms of potash also costs £265. If 600 kilograms of potash costs £265, then 1 kilogram potash equates to 44 pence. We know that there's approximately 8 kilograms of potash in every tonne of FYM applied, so 8 kilograms times 44 pence comes to £3.52. Therefore, the potash value in every tonne of FYM is £3.52 based on current market values for fertiliser. When we collate these figures, this is what we get. 42 pence worth of nitrogen in every tonne of FYM, £2.02 worth of phosphate in every tonne of FYM, and £3.52 worth of potash in every tonne of FYM. The total value of all the major nutrients then comes to £5.96 worth per tonne of FYM. As an example, if you're applying FYM at a rate of 20 tonnes per hectare, this could amount to £119.20 worth of nutrients per hectare of the FYM application. The same methodology can also be used to work out the monetary value of nutrients applied to land for different livestock manures and organic fertilisers. Estimated nutrient values for a range of organic fertilisers are provided in the SEC Technical Note TN 650 called Optimising the Application of Bulky Organic Fertilisers. Next, we're going to use the same principles to estimate the monetary value of slurry. This calculation is slightly different to the FYM calculation due to the fact that a proportion of each of the nutrients is utilised by the crop. If you already have access to a copy of Technical Note 650, please refer to Table G, which provides details of how to work out the percentage of total nitrogen available to the next crop. The proportion of total nitrogen available to the next crop depends upon several factors, such as, first of all, time of application, and here we're going to assume a springtime application for our example. It also depends on the soil type, and we will assume it's an other mineral soil. It depends on the receiving crop, so we're going to assume it's a grass crop that we're applying to. It also depends on whether the slurry is incorporated or not, and we're going to assume that it's not incorporated. And it also depends on the dry matter of the slurry. We're going to assume a dry matter of 6%. Then finally, the uptake of P and K depends on the soil P and K status. We are going to assume that the soil P and K status is low in our example. Table G from Technical Note TN 650 shows the different percentages of nitrogen that may become available to the next crop. Working across the table from left to right, you will see that the percentages of nitrogen available to the next crop vary according to, first of all, timing of application. So the first two columns there show autumn applications. The next two columns show figures for winter applications. That column there shows springtime applications, and the last column on the right shows summertime applications. Figures also vary according to the method of application, so whether it's surface applied, being ploughed in, band spread or injected, how soon it's incorporated, and also the dry matter of the slurry. In our example, we are going to use a 6% dry matter, so from that row that's highlighted, the second row that's highlighted there, we can conclude that roughly about 35% of the total nitrogen is going to be available to the next crop. In this second example, we're going to look at the application of a 6% dry matter slurry. As with the FYM calculation, first we need to consider the nutrient values within each cubic metre of slurry being applied to the land. Here you can see that 1 cubic metre of a 6% dry matter slurry is expected to contain around about 2.6 kilograms of total nitrogen, 1.2 kilograms of nitrogen which is readily available to the next crop, 1.2 kilograms of phosphate, and 3.2 kilograms of potash. As per our earlier example, we're going to use the following products as our sources of nitrogen, phosphate and potash. So ammonium nitrate is going to be used as a source of nitrogen, priced at £242 per tonne. Triple superphosphate, or TSP, is going to be used as a source of phosphate, priced at £290 per tonne. And muriate of potash is going to be used as a source of potash, priced at £265 per tonne. In order to calculate the monetary value of the nitrogen contained in cattle slurry, we need to consider the following. As before, the ammonium nitrate which we're using as our source of nitrogen contains 34.5% nitrogen. Therefore, 1 tonne or 1,000 kilograms of the physical product is going to contain roughly 345 kilograms of nitrogen. We can say that if 1 tonne of the physical product is costing £242, then 345 kilograms of nitrogen is also costing £242. Dividing both sides of that equation then by 345, we can work out that 1 kilogram of nitrogen equates to roughly 70 pence. This time, however, the calculation is based on only a proportion of the total nitrogen becoming available to the next crop. We know that there's approximately 2.6 kilograms of total nitrogen in every cubic metre of slurry being applied, but in the springtime, only 35% of the total nitrogen is becoming available to the next crop. This means that 0.91 kilograms of nitrogen is readily available in each cubic metre of slurry. And this means that the nitrogen in each cubic metre of slurry can be valued at 0.91 times the 70 pence, meaning that there's 64 pence worth of nitrogen in every cubic metre. Again, we repeat more or less the same calculation to work out the monetary value of phosphate in cattle slurry. So using triple superphosphate as our source of phosphate, we say that triple superphosphate contains approximately 46% phosphate. Therefore, 1 tonne or 1,000 kilograms of the physical product contains 460 kilograms of phosphate. If 1 tonne of product costs £290, then that equates to saying that 460 kilograms of phosphate also costs £290. If 460 kilograms of phosphate costs £290, then 1 kilogram of phosphate equates to 63 pence. With cattle slurry, however, only 60% of the phosphate becomes available to the crop in the year of application when soil P status is low. We know that there's approximately 1.2 kilograms of total phosphate per cubic metre of cattle slurry. Therefore, 60% times 1.2 kilograms means that there's 0.72 kilograms of phosphate that's readily available per cubic metre of cattle slurry. 0.72 kilograms times 63 pence means that the phosphate value in every cubic metre of slurry equates to 45 pence. Similarly, for potash, we can say that muriate of potash as our source of potash contains approximately 60% potash. Therefore, 1 tonne of the physical product is going to contain 600 kilograms of potash. If 1 tonne of product is costing us £265, then this equates to saying that 600 kilograms of potash is also costing us £265. If 600 kilograms of potash costs £265, then dividing both sides of that equation by 600, 1 kilogram of potash equates to 44 pence. With slurry applications, approximately 90% of the total potash becomes readily available when soil K status is low. We know that there's approximately 3.2 kilograms of total potash in every cubic metre of slurry. Therefore, 90% times 3.2 kilograms equates to 2.88 kilograms of potash per cubic metre of slurry. Therefore, the potash value in every cubic metre of slurry equates to 2.88 times the 44 pence, giving us £1.27 worth of potash in every cubic metre of slurry. The figures shown here summarise what we're left with when we collate the figures from our previous calculations. We're left with 64 pence worth of nitrogen in every cubic metre of slurry, 45 pence worth of phosphate in every cubic metre of slurry, and £1.27 worth of potash in every cubic metre of slurry. This means that the total value of all the major nutrients in every cubic metre of slurry comes to £2.36. As an example, if you're applying slurry at a rate of 30 cubic metres per hectare, this could amount to roughly £70.80 worth of nutrients per hectare of land being spread. We can apply these same figures to evaluate the worth of the slurry that may be held in a typical slurry store. Take for example a farmer with a 500,000 gallon slurry store. The 500,000 gallon equates to roughly 2,272 cubic metres. At £2.36 per cubic metre of slurry, this means that the slurry in the store could be worth approximately £5,362 relative to the nutrient value of the slurry and the price of inorganic fertilisers on the market today. That concludes the slides in this short guide. Although we have looked at two worked examples containing FYM and slurry, the same principles can be used to work out the available nutrients for other organic manures as listed in SAC Technical Note TN 650, optimising the application of bulky organic fertilisers. That said, the proportion of total nutrients that becomes available to the next crop can vary widely between individual circumstances, depending on timing of application, method of application, soil type, and soil P and K status. In order to obtain meaningful data, it is important to work with an accurate analysis of the manure that is to be spread. Manures and slurries can vary widely in dry matter content and nutrient content, and the absence of an up-to-date analysis makes any results open to question. It is also important to acknowledge the need to comply with current regulations regarding the spreading of livestock manures and organic fertilisers. Preparing a RAMS map, or a risk assessment for manures and slurries, should help to reduce the risk of spreading on areas of land where it may not be appropriate, such as steep sloping land. Cross-compliance regulations, including NVZ regulations, also need to be adhered to accordingly. Further information on the content of this guide is available from the Farm Advisory Service National Advice Hub, telephone number 0300 323 0161, or email advice@fas.scot.